What we're going to be looking at today is predicting products. We notice that we've got the reactant side filled out for us, but we don't have anything on the product side, so we're going to have to create that product side. We're going to get rid of this one by to number 1. Let's get rid of number 3 because we don't really see a lot of these problems either, and we'll just do the ones that were more frequent. We'll take a look at number 2. To start these problems, you're going to locate the element or polyatomic ion on the periodic table, and above that element you're going to write in what the charge is of just one of those elements. So even though I've got 1 sodium here, I'm still just going to write what the charge of 1 sodium is. So charge of sodium is what? +1. So above the sodium, small, I'll write a +1. What is the charge of an iodine? -1. And then we'll go over to our next molecule. Calcium, what's the charge of that? It's a +2. Now, I've got 2 chlorine here, but I'm just writing the charge of 1 chlorine. So the charge of just 1 chlorine would be what? -1. It's going to be a -1. And we can now construct the product side. What's going to happen is the positive from one molecule is going to come together with the negative of the other molecule. And to make it on the other side, I'm going to use these charges. So an Na with a +1 comes together with a Cl with a -1. What would that create here? It's going to make NaCl. The +1 and -1 cancel each other out right away. Then I'm going to make my other product in this case, so I'm going to plus and then a little line for balancing. The Ca is a +2, the I is a -1. So these are going to come together. And how is that going to, or what's that going to be over here? CaI2. And it's important that we write the positive ion first, the negative ion second. So cation first, anion second. So CaI2. Then we need to balance this because it's nice. We look at the NAs, Na, 1 and 1, that's easy. When the iodine, I is 1, I is 2. So what should I put here? 2. Yeah, on the reactant side, place a 2 here to get the iodines equal. But now I have 2 iodines, and by putting this coefficient of a 2 here, the sodiums are 2. So what do I need to do over here? 2. Yep. And now that I've got these sodiums fixed, well, I got to take care of the chlorines. Oh. And 2 chlorines, so everything's balanced now. What type of reaction is this? Yeah, this is going to be a double displacement. If we want to just abbreviate it to save some time, that's fine. Let's go to 4. Hydrogens. What's the charge of a hydrogen? +1. What's the charge of an NO3? -1. Find that in the bottom part of our periodic table. All right, moving on to the next one. Manganese. What's the charge of a manganese? What do we decide on? Plus what? 2? I agree with the +2 because when I take a look at this one, we can't like look at manganese and know what it is immediately. We have to look at the anion, or this polyatomic ion here first. It says that there are 2 OHs, and they have -1 charges. And there is 1 manganese. So if this total -2 here needs to be canceled out, this manganese has to be a +2. So manganese +2, and then charge of hydroxide, we already mentioned that, is a -1 from the bottom part of the periodic table. So now we need to put this together. H is going to come together with the OH. Mn is going to come together with the NO3. And what's this going to make? Not at the type part yet. H plus 1, OH minus 1 makes HOH. This could be rewritten as H2O, but for balancing purposes, I would recommend just leaving it as HOH. Alright, then for our next one, Mn and NO3, you got a plus 2 coming together with a minus 1. What's that going to be? Do I need more MNs or NO3s to cancel these charges out? More NO3s. How many total NO3s would I need? 2. So we'll say we need an Mn. Then since we need 2 of those NO3s, we'll put parentheses NO3 with the 2 after it. Is it balanced? No. How many NO3s here? How many NO3s here? 2. So we need to place a 2 on the reactant side. How many we'll call these in-front hydrogens. How many in-front hydrogens do we have here? 2. How many in-front hydrogens do I have here? Uh-oh, so this has got to be a 2. And by placing this 2 here, that changes my OHs. I've got 2 OHs, but I've got 2 OHs, so that's okay. 1 Mn, 1 Mn, we're all good here. So 2, 1, 2, 1. And then what type of reaction is this? Yay, it's a double again. Let's do one more here. How about 5? What's the charge of silver? +1, very good. It is a transition metal, but silvers are always going to carry a +1 charge. What about an NO2? It's going to be a -1. Polyatomic ion, good. Then look for barium. What's the charge of a barium? +2. And charge of an SO4? -2. So we'll put them together. Ag is going to come together with SO4. Barium is going to come together with NO2. And so let's look at the charges. +1 coming together with a -2. What's that going to make here? Yeah, Ag2, because we need 2 of these +1s to cancel out this -2. So Ag2, SO4. And we got a barium coming together with an NO2, a +2 coming together with a -1. What is that going to make? +2, -1. We would need 2 of these, right?
Yep.
So BA NO2 with the 2 on the outside, showing that we need 2 of those NO2s. Is it balanced? Nope. How many silvers do we have here? How many silvers do we have here? Uh-oh. So what needs to be here? Put a 2 here, and that fixes the silvers, but now I've got how many NO2s? 2, but how many do I have over here? Good. 1 barium, 1 barium, 1 SO4, 1 SO4. Everything is good. What type of reaction? Yep. Let's go find another one. Let's take a look at this one. What type of reaction is this? Combustion, because we have O2 on the reactant side. So, combustion reaction. Now, there's a rule, we kind of mentioned it in the notes, and I said, we'll talk about it in just a moment, like, a couple of days later, don't worry about the rule right now. But now that rule is going to become important, and that rule is also here on the front. Combustion reactions that contain carbon will always make CO2 and H2O on the product side. So we don't have to worry about charges and matching things up for this one. Our products are going to be CO2 and H2O, and that makes finding that really easy. But we will have to still go back and balance it. Now, the way that this molecule is written is for like organic chemistry, and it kind of gives chemists a way of figuring out how the atoms are bound to each other, but we can just simplify this and reduce it so it's more like we're used to seeing. So there are essentially 2 carbons, there are 4 hydrogens, and there are 2 oxygens. So now let's balance it. How many carbons here? 2. How many carbons here? 1, so that's got to be fixed. Put a 2 here. How many hydrogens? 4. How many hydrogens? What's got to be here? Put a 2 here to fix the hydrogens. And now let's look at the oxygens. 2 times 2 is 4. 2 times 1 is 2. So we've got 4 plus 2 is a total of 6 oxygens on the product side. What do we want to do for these numbers to get it to be 6 for the oxygens? Yeah. Yeah. Put a 2 for that oxygen. 2 times 2 is 4, plus another 2 is 6. We got all of the atoms together. And then the last one, we'll take a look at this one. Ag, what's the charge of a silver? +1, yeah. Transition metal, but +1. NO3, what's the charge of that? -1. And what's the charge of a lithium? Okay. So how is this gonna what's the other side gonna look like? Am I putting the Ag and the Li together, or the NO3 and the Li together? Yep, NO3 and Li. So the positive here is coming together with the negative here, and this positive is just going to be by itself. And the order doesn't matter. So if I wanted to write the Ag by itself first, that's totally fine. And that's what I'll do for this one. And then the Li and the NO3, a +1 with a -1, they just cancel out. So Li, NO3. And then 1 Ag, 1 Ag, 1 Li, 1 Li, 1 NO3, 1 NO3. Those are all balanced already too. But what type of reaction is this? Yeah, single replacement. So there are some things that we can do to figure out types of reactions quickly, like 1, 2, 3, 4, that was a double displacement. 1, 2, 3, 4, that was a double displacement. 1, 2, 3, 4, that was a double displacement. 4 charges, double displacement. But if we look at 10 here, 1, 2, 3, single replacement. Or we've got an O2 on the reactant side by itself, combustion, and these are the only options for the product.